Okay, so in this video, I'm going to take you through properties of logarithms and just kind of point out a couple of parallels between exponent rules. If you have a base like a to the m and a to the n, when you multiply the bases, you add the exponents. So I just want to draw a couple of parallels because logarithms are exponents. You can kind of start to see how these ideas relate to each other. So with log properties, this is just kind of your reference sheet, and there are videos on how to use these. But for now, just take notes and use this as reference in the future. If you are multiplying two numbers in the logarithm, so this is in the argument of your logarithm. If you're multiplying two numbers like a and b, then you can actually expand. We call this expanding the log as so. Log of a plus log base b of b. So notice here that when we're multiplying the two numbers, I can expand this over addition, which is similar to the multiplication rule for exponents, where you then add the exponents. And guys, there are proofs on all of this stuff. You can look it up online if you're interested more in about how this gets to here. But I just want this to be kind of a reference sheet for you for now, so I won't go into all those details. Okay. So if I'm taking log base b of a divided by b, so notice how I have two numbers in the argument that are being divided. Well, you could almost guess what's going to happen by looking at this rule over here. When I multiplied, I would add, but if you're dividing, just like with exponents, you wind up subtracting. So it's log base b of a minus log base b of b. Okay. And then this here is if you have a number that you're taking the log of, and it is being raised to an exponent, there's this property where the exponent is brought down in front and is multiplied to the log. All right, and then just a couple of things. So think about this for a moment. Notice how b is the base of the log, and I'm saying b to what exponent is equal to 1. So essentially I'm saying, well, b to what exponent, like x, is equal to 1? And it's really interesting here that b could be any possible number. So any number to this special exponent gives me 1. Well, if you're kind of looking over here and tracking with me, you'll notice, well, the exponent has to be 0. So it's actually pretty cool that the log with any base, log of 1 is always equal to 0. So that's true for any base. All right, and then our last one, log base b of 0. This is like saying, hey, b to what exponent gives me the number 0? And let's think about that for a minute. If I were to say take like 2 to an exponent or 3 to an exponent, could I ever make it equal to 0? If I did something like 2 to the negative 5th power, that would give me 1 over 32, which granted is a very small number, but it's not equal to 0. So there's actually no possible exponent that I could put in here to get the actual number 0. I could get very, very close by increasing this negative, but it's never going to be equal to 0. So this actually doesn't exist. Okay, and now let's think in a similar way. Could I raise a base to an exponent and get a negative number back? Is there a way to do that? Well, this is actually a good example to look at too. So like 2 to the negative 5th power gives me positive 1 over 32. Negative exponents just mean fractions. They don't turn your number negative, they just turn it into a fraction. So if you're starting with a positive base, there's no way to raise it to an exponent and get a negative number back. So this generally doesn't exist either. The only way that you can take the log of a negative is if the base itself is negative. So if you imagine like negative 2 being your base, and this is rarely ever done, but if I were to raise it to like the 3rd power, then I could get negative 2 times negative 2 times negative 2, and that simplifies to negative 8. So if your base is negative already, it's possible to take the log of a negative number, but generally it's not possible. Okay, so these are your log properties, and think about how they're similar to exponent rules to help you kind of remember those sorts of things. You're not going to cover it in this lesson, but in, I believe, the next lesson, you'll look at the change of base formula, which is just this formula here. And you can kind of work through and just use this as reference for practice problems later. But for now, just go back and reference these. Again, like I said, if you're interested in how exactly these came to be, there are proofs online that you can look up and kind of understand more of the mathematics behind it.